Our final speaker in our Big Data and HPS conference is Samantha Vilkins from Australia, Queensland University of Technology. And Samantha will tell us about the oxymoron of coding uncertainty in big data out of context. Thank you very much, Samantha, for joining us this early. As you said, it's 5 a.m. in the morning for you. Really appreciate it. So please take it from here.
Hello, everyone. I'm currently a postdoc at the Digital Media Research Centre at QT, but this is part of my PhD work. So if you have any questions, there's a lot of other work that goes along with it. They're going to let me, yes. Very quickly, I'd like to do acknowledgement of country, that the university and where I work and live is based on Turrbal and Yagara lands. And I especially like to make this note because the work that I do is about big data, but especially government statistics and that sort of work. And I speak about it less in this presentation, but often I'm discussing how statistics are colonial statecraft and how the sort of primary frameworks that these things lay out don't allow for expressing culture in very different ways. So I like to make that note as one of the primary examples of the things that I'm going to talk about. Today, I'm talking about interview data from my PhD, and this is just one of the clearest examples of what I'm going to talk about, which is that I spoke to data professionals about communicating uncertainty. And one of them said, oh, you know, it's more like the vibe that you might be trying to communicate, not the exact number, just sort of the vibe. And I'll return to that and those sort of dichotomies in a moment. So in the next about 20 minutes, hopefully, I'm going to explain my approach of big data and sort of connect it more to ideas of quantification, because that's how I entered thinking about these sort of things. It's the base thinking of categorization and statistics rather than computational methods necessarily. Summarize the data that I'm drawing on, then talk about some conceptualizations of uncertainty and the impacts on coding and communicating. And then hopefully to finish up a little bit about the truth utility tension of data and doing HPS. This is from the corporate papers. Not to make too big a point from it at all, I was just grabbing text, but to talk about that common dichotomy between using individual case studies and the risk of cherry picking, shoehorning in preconceived assumptions and data bias. And the idea is sort of that this comes up a lot, that qualitative data is sort of not simplistic, but that it's like rich individual data, and that this qualitative that's quantitative, it's all the boons of using quantitative large-scale computational data is that the law of large numbers will sort of wash out all those errors. And then you have this other side of qualitative research where they're not even seen as errors, they're seen as rich local variance. Of course, this isn't particularly true. It is true in that some elements of that is present, and certainly present in how some people do the work, but it's overly simplistic, as all dichotomies are. But the thing is that leads to solutions like increasing the resolution of data. So you get attempts to code in uncertainty and nuance, sort of what I think of as brute forcing, with maximum inputs for maximum outputs, and trying to solve uncertainty by just adding more data. So if I want to feel healthier, you know, I'm going to take all these new metrics and measure more and more about myself to try to get to the true value, because that's how you think about uncertainty if you're thinking about this. But the information loss, the way I like to think about it is that the information loss is the benefit. The information loss is the process of quantification. You get this larger surveillance view, and it's not, oh, but you do so and you lose the information, and that's the downside. That's the crucial point. And I'm doing everything wrong here, rushing through these slides and putting large quotes up on the screen. But this is just something that's really helpful for the work that I do, the quotes that I have, the people who are doing this work. And specifically, this is a paper called A Sociology of Quantification. It's fairly central to the work I do. And they're quoting all like previous work from organizational scholars. So this is specifically looking at information flows in an organization, talking about how raw information or, lived experiences are collected and compiled by workers at the bottom of hierarchies, and then manipulated past, moved upward, and transformed to make accessible to people who are making decisions. I really want to focus on that quantification, big data, all of these processes are to make decisions. You might not think your research is making decisions, but that's what it's designed to do. And they call this uncertainty absorption, yada, yada, yada. And they talk about just down the bottom here that the result of this, the consequence, that decisions seem more obvious. And obviously they're sort of framing it as if to say this is unintentional, it's biased, that these people, the people at the top will be making decisions based on data which isn't objective, which isn't, it's been manipulated in some way. But this, again, is the point. We have series of preferences which are used to clean the data before they reach the people who have to make the decision, to make it more obvious to them and to make it clearer. That's the system sort of working as intended. And I have the note that says the issue is actually in hard coding those unique decision-making priorities so that you can't go back and use the data for something else. That classic problem of you can't unbake a cake, right? You can't unmake the data set to use it for another direction. There are possibilities if your use cases are very similar, but if you want to use data efficiently, you're probably putting it down for your use and it's harder to get back to use it for something else. And this is a quote from one of my participants, sort of about that exact idea. This is someone who worked, they were a government statistician, and they were saying that they have trouble reminding themselves on a daily basis that most government data isn't collected with the idea in mind of doing what I'm doing with it. And how difficult it is to recode things or remap things to the new purpose. This sounds quite sinister as well. They just mean that the statistics work he was doing wasn't quite lining up to the best data they had available. So just quickly, the data that I'm working on is really focused on mundane decision-making of statistical professionals. And those professionals were about 50 people from government, academia, media, consultancy, politics. Some politicians, some lobbyists, some staffers, academics, statisticians, journalists, data journalists, pretty much every data journalist in Australia, effectively, working at that national public debate level. So not really private consultancies or things like that, things designed for public consumption and debate. And I asked them about their daily heuristics, their justifications and motivations. So I really didn't want to hear about their sort of life journeys or their, life motivations or a particular case. I wanted to hear about what they do usually, if that makes sense, and about data sourcing, critiquing, cleaning, how they communicate it. And I was heavily reliant on this framework of statistical realism and different conflating ideas about what the data is for. I'm going to explain that really briefly, though it may feel like we're going in circles. This will be very obvious to anyone who's even blinked in the direction of the social construction of science and knowledge. But I really like this outline from statistician, sociologist Alec de Rosières in early century, I suppose, which clarifies it in the context of using numbers, using data. So he has this question framework, which is just not this simplistic. He writes it far more eloquently, but he says, the things that this person is measuring considered to be real and external to them, or are they constructs? Are they socially agreed upon constructs? Do they know and mention that in their work? And then besides that, do they use the descriptive language of science to do the work, or do they use this language of prescription of action? And they're colored this way to say that 3 of these are more stable, real ideas, and 1 is that sort of black box, anything goes category. And to get a feel for the data that I'm looking at, or the data that I have, these are those 4 categories and quotes from my participants. So this is across different domains. That metrological, real descriptive idea is someone literally saying to me, you know, statistics is descriptive. It describes what's actually happening. It gives you quantifiable measures. I wonder what they were talking about. I think like people who there was people in my data set doing statistical work, not on social figures so much. It is things like weather statistics, bushfire data and things like that. So they're very inclined to think of things in that way. Second, this was a business journalist actually defending why they don't fact check business information. But the construct, they know it's a construct. They know that money is something that we could all decide tomorrow isn't relevant. We don't want to use it. But it's a very descriptive, precise language. Double entry bookkeeping is, I got so many layers of bounds on it to be correct, saying that, you know, if it's financial information, it's indisputable, numbers are going up and down. Moving over the column, the ABS here is just the Australian Bureau of Statistics. You don't need to remember that, but someone who's, once again, thinking they're measuring reality, but the line of reality is what the government says. And they're using that language of making arguments that what does the government say about that? What does the government data say? Those are what my arguments can use, which is a different method of, you know, a mindset of using statistics. And finally, we have one which is more about the rhetorical use of statistics, how malleable they really are to say that, well, you know, to make arguments, statistics are important because they add a lot of weight. And of course, what I'm talking about is all in that last column, right? That the participants don't think it is. All statistics, especially social statistics, I suppose, are negotiations, different use cases, different biases getting you to different points, and opening up and changing that black box. But some agreements, some language, some vocabulary is so decided that it feels like some of these other categories. Where am I? Yes, so what I was talking about before about information loss is understood by the professional as data cleaning. It sounds more regular when you say it like that, but it's information loss. You're trying to remove information that you don't think is necessary. And in the broader interviews, not just when I asked about uncertainty, some of them view massive intervention in the data as no consequence. But this shifts depending on context. And you might say, obviously, it depends on context. What else would it depend on? But what I mean is that, for example, one of the hypotheticals I had to clarify, if they had no idea what to say to me, which happened in a lot of interviews, was, for example, you've got 2 different cities and you're trying to merge data sets from each of them, but they have different statistical systems, different categories and codes. How would you merge the 2? And for some topics, some of them would say, that's no problem. I'd come up with a new code, easy. And for others, they would say, oh my God, I would never. I wouldn't even try. If there are different coding systems, that's not my job. I would bring in an expert. We would never do that. All of that sort of hesitancy. And that wasn't a particular risk profile of personality or of education or of field. It depended entirely on what topic they were looking at, and especially whether the sort of statistics they were looking at were which one of those 4 regular categories, right? You might be more inclined to change something around if you think it's settled, if you think it's already been manipulated enough. But if it feels more like a live, contestable, debatable issue, the statisticians were far more obsessed with maintaining a sense of reality that didn't involve them being seen to be made decisions at all. Somebody else makes the decisions. That's pretty crucial. And just to reiterate this point that all data production and translation and communication, it's all biased uncertainty absorption. There's no stage at which you're producing data and communicating it, and that's doing different work. It's all the same thing. I thought I'd remind myself to talk about why coding uncertainty is an oxymoron. At this point, made the most sense. There's no way to hard code in actual uncertainty, right? If you don't know something, you can't reflect that by adding in information to your data set. And I spoke a bit to participants about how they visualize uncertainty. Some of them were very visual data journalists, but it's the same challenge that they're making a decision to add something to the data, graying out maps, or adding in, some of them spoke about animations to move the data around in a sense that it was sort of jittery. These have the same problem where they're clarifying data, they're still adding in a refinement or new information. If you're actually uncertain about the data, you would not be using it, was what some of them was sort of saying. But this relates to these two clear divergent conceptualizations of uncertainty that they had, which is one that was really calculable and one which was far more intangible. And this has onward influence for then how they thought about cutting it out for public consumption or pulling it in. So these two divergent conceptualizations of uncertainty are pretty much exactly what you see here. One's the very, very standard. You can calculate error bars, confidence levels, things of that nature. It's very precise. It's given in the same form as the other data. It's calculable. On the other side, I've hit the same problem that everyone does. How do you communicate uncertainty? But was described as that more of a vibe of the data, something completely intangible and inherent in the work that they were producing. And this is rooted in the ideas of statistical realism, which again varies by context rather than any one person thinking that they were rooted in one particular idea of statistical realism. So their ideas of uncertainty also change according to what sort of area they were in. And so you have this real metrological realism of descriptive, precise, calculable error that's a data point plus an error. Versus this idea of uncertainty that's just going into the situation. How much uncertainty did they have before they even decided to make the number? A lot of economic forecasters were talking like that, that they couldn't even imagine how to put an error calculation on it, even though they ended up with a number of this will cost us $6 billion. They couldn't tell you how far off that number was from reality because the whole situation was hypothetical. Or even scientists would mention this sort of uncertainty. And in that way, it aligns with existing typologies of uncertainty, which exist broadly in sociology of science, but specifically in science communication in a really practical sense, in terms of scientific uncertainty or measurement uncertainty. But most people really only spoke of either it being calculable or incalculable in their work. These are just a few sort of from one spectrum to the other. Someone saying, you know, when I first started, I was always putting error bars on every plot I ever produced because to statisticians, that's important. That's the most important part of it. And then they were saying that their boss told them, absolutely not, stop doing that. And then versus the idea of, oh, if you're talking about testing for sensitivities, there's a lower bound and an upper bound, but oh, it's not statistical. Like, oh, I couldn't actually print that. That's not part of the data. Saying that, oh, you can talk about different people having different numbers, different estimates, but you're talking about different methods, not about actual error or uncertainty. That was actually one of the really interesting ones, saying that if you picked an entirely different method, you couldn't understand the relevance between them. Someone else was, this giant thing made up from thousands of different data sources is about measuring inflation, the like national consumer price index. saying that that sort of work, even though it's immensely statistical and numerically precise, could never have an understanding of uncertainty because of that exact law of large numbers. There was just no way to think of it that way. And finally, too, it's more of a vibe, trying to communicate something that's more of a vibe than an exact number. And very briefly, this impacts the choices for further coding and communicating. Because if you think of it as something calculable, or I guess in your work, if it is something calculable, if it's a real known unknown, people thought that, well, it should be part of the whole report, right? It should be in the appendix, it should be printed in the graph, but at the same time, it's really, really easily removed. It's not the number that you're reporting. And that means that some people thought that it was wholly unnecessary, that they could calculate uncertainty, but that wasn't the work that they were doing. Versus this intangible sense where some people said, well, it's so intangible, so inherent to the work that I do that I have to mention it. It's so much a part of how I tell the story of the data that we don't really know why we went with this one over this one. But other people said, well, it's impossible to include. It's so inherent in the data that I couldn't possibly tell you how uncertain it is. And that's essentially where I'm wrapping up, although I am open to questions. I was thinking about these questions again from the call, saying that this data and these concepts I've spoken about don't really offer useful concrete answers apart from deep understanding of how these decisions are made in practice at those data cleaning levels before you even talk about computational work or second level analysis. But that everything is an end order text. Everyone is always refining the data. As you first collect it, as you hand it over to someone else, as all these hands work on it, everyone is refining things to new biased use cases, different priorities to make different kinds of decisions. And I guess my point is this isn't a new problem. There's sort of this fear in some of this wording, and not just here, but in critical big data science, about, oh, but there's this view from nowhere, there's this other layered context, there's this other level of interpretation. But that's very, very familiar to historians. I'm not one myself, I'm a mathematician first, but the idea that someone writing down what happened as a primary text who was there still has a very biased perspective. They might still go in and edit things later that you can't really quite tell because it's in the original document. And also that pattern detection isn't exempt from this, right? I have colleagues, we're a very big computational research center, and I have colleagues who still use the language of, oh, but I didn't train it on any data, it's objective, it's just picking up patterns that are in the data set. But there's no way to do that which doesn't include some level of preferences that you've pre-coded into it, right? Or you've prepared the data to be used by this AI in some particular way. And so it's not really a negative, or I'm not saying that you shouldn't do it, but to have more awareness and clarity about exactly the priorities you're putting into analyzing this data so that other people know if they're using it differently or what might happen if they use it. And very finally, I love to use this quote to sum up some of the things I've been talking about. It's quote from Wittgenstein in the first Foundation of Remarks in Mathematics, just talking about the philosophy of whether maths is true or not, which is a problem that I am fascinated by, not directly analogous to big data, but he talks about why do we learn to count so precisely with endless practice, with merciless exactitude? And it's exactly because it is proved to pay, not that it's true, but it's usable, and above all that it's used. There's a lot of fear and uncertainty or rightful criticism that a lot of big data sets aren't as objective as they seem, they aren't as unbiased as they seem, they're not true at all, they're not valid, etc. But they're useful, they offer something that we can't get elsewhere. They're still perhaps more useful than using individual case studies to try to prove your point. And that's how I like to think of them, that there are a lot of limits, but it's still a very useful tool. And that is all. Thank you very much.
Thank you very much, Samantha. This was very, very interesting. I myself have several questions, but I would like to open it for people in the room. Anyone has any questions? Yeah, I guess I'll start. I worked on a visualization of incomplete and imprecise historical data because I'm interested in how we diagrammatically visualize. And I was wondering if in this work or in this an adjacent work that you rely on, is there any differentiation between imprecision, incompleteness, and uncertainty? I'm working mostly with people who are in computer science and also semantics. They're trying to figure out how to conceptualize these things, specifically for the sake of storing these things in databases. Let's say, how do you store an incomplete or uncertain or imprecise historical data? That's very important for many fields, not just academic history, but also, let's say, medical record keeping. Somebody says, oh, I had this illness 10 years ago, but they don't know exactly when it started, when it ended. Or they say, I was sick for about a month, sometime between the age of 5 and 7, for instance. So they know it's for a month, but so effectively they do distinguish between imprecision, incompleteness, and uncertainty. And with your permission, I just want to share a quick, it's easier to explain if I were to just share it with your permission. So on a diagram like this, I don't know if you can see it. So this is the bar is meant to represent a temporal period for a certain process or a time period, let's say historical something. And so whiskers like this, they indicate the imprecision of the information. Let's say we know that the period ended sometime before, sometime after this year and before that year. So we call that imprecision. On the other hand, this one is not only imprecise, but also incomplete. When we know it started after this one, but we really cannot put any meaningful age here, or things like this also happen. They say it started earlier than this period, earlier than this year here, and ended earlier than this one. But again, it's very difficult, especially for this particular one. So this would be both imprecise and incomplete. And on top of these two categories, they also have uncertainty, which is you can assign a probability or some kind of a number as to how much you are sure that it happened, that this is in this number or that number, and so on and so forth. So it's like 3 distinct categories they're dealing with, each one sort of being handled in a different way. I'm going to stop sharing this. Is there a similar distinction in your field, or are they sort of putting all these categories together?
Thank you very much for the question, because that's actually quite interesting and something that I was thinking of as I was trying to understand this data in the sense of historical data sets or these sort of data sets. I think the most important note is that the questions I was asking was about how they use it in their day-to-day work. So I think some of them understood if I really pressed, especially because some of them had PhDs in sociology of science. If I pushed, they could articulate, oh, what I'm really talking about here is this kind of uncertainty, or I'm really talking about the incompleteness of the data, or I'm really talking about X, Y, Z. But in the sense of when I said, oh, you know, just can you tell me a bit about how you deal with error and uncertainty? That's how I phrased the question. What was most striking is that they did clump together all those different terms into those two things, that either it was something they had a number for, that they could give a number for, even if it wasn't from the data itself. As you say, trying to measure uncertainty by saying on a scale of 1 to 10, how uncertain are you with it? That to them is calculable, it's something they can work with. That's how they spoke about it. And they had a series of other questions to ask themselves. Well, do I include it? Do we print this in the data? Do we include a column that does that? Or is it just something about these people don't really remember when they were sick? We we can't possibly ascribe anything top down from our end to translate that into a mathematical system. They just really don't know. It's just something to do with the data that we can't possibly manipulate. And so I guess, yes, it's the answer that a lot of people had those different typologies, but it wasn't how they were thinking about it. What was extra interesting as well, the second part is that the data journalists were the real people who had to think about this problem, because if they're reporting on extreme weather events, but they don't have information for one area, what do? Do you make it all grey? Do you make it exempt somehow? You have to do something. And they had a lot of different creative ideas for how to talk about that and how to manage it. So knowing semanticists are on the job is actually very important, because it feels like a lot of them would benefit from those terms being more commonplace and more practical in the work they do. The last thing I wanted to mention is that someone early on in the interviews was a statistician working with hospitals. So exactly that question of medical data. And it was really interesting because a topic that really came up would be, well, when do you intervene in the data, right? Instead of whoever organized it for you, if that's the sort of relationship. And that person was saying, oh, sometimes they had to fix it and they had to go back to the hospital and tell them they were wrong. But it was because of things like that they said, oh, obvious things like admission time was after discharge time. I'm like, well, obviously that's not right. So we can just change that. But if you think about it, the reason they have that authority is because time is such a standardized measure that they're all using the same context, which is a bit pointless to say in that example. We know that, but it applies to other examples about, well, what shared context do you actually have, and how fragile is your shared context in other settings, with the full opposite of knowing for certain this is wrong because time is the wrong way around. When are you not so certain if you are wrong or not because you don't have any idea about that shared language? Yes, those are the thoughts. Thank you very much.
Thank you, Samantha. Paul?
Yeah, so in one of your early slides, you talked about something being either a social construct or referring to the world. It doesn't seem like that ought to be dichotomous. It seems like you take temperature, for example. Temperature is very much a social construct, as like Cheng's work showed, but it also refers to something in the world. Isn't all data perspectival in that sense? It's constructed, but it also refers to the world.
Thank you. And yes, unfortunately, not a very interesting rebuttal, but an agreement. I agree entirely. And so does Derosiers, who wrote this out. He was talking about how it's used in practice. Mm-hmm. So if you ask someone researching temperature, they might say, well, obviously, it's also constructed and all of these things. But if you ask a meteorologist if it's real, they'll say, obviously it is. It's very, very important to my work and my conclusions and my mental health and the mental load of doing this job that I think it's numbers on a sheet of paper that are external and no one is changing. That's what that question is about, whether they're considered external objects of some semblance of reality, or whether they're considered live and debatable and constructed.
I guess I don't see that as either or. I see that as necessarily both.
That's because your particular approach.
I'm sorry, go ahead. I interrupted.
That would be because your particular approach is in one of those other boxes, right? If you tried to speak about this to someone who works in very, very hard numbers and never thinks about this, it's about what the arguments they're making in the moment. It's not necessarily what they're actually doing or the truth of the actions to the data. It's how they would consider it in the work they do. So it's entirely about perspectives and attitudes, especially if you think of the rhetorical arguments used by people in Silicon Valley doing big data. It's the arguments and the rhetoric they're using rather than how they're actually manipulating the data. If that makes sense.
Thank you. Stefan?
I'm wondering if you encountered an answer that went something like, it depends who I'm talking to. Let me explain what I mean. If I'm a scientist and I'm communicating results to my members of my scientific community, I need to be very cautious about my generalizations. There's a lot of front loading of my own uncertainty. If I'm talking to the public and say that it's a topic having to do with that's climate change relevant, right? Where that uncertainty can be kind of not weaponized exactly, but put to some kind of political end. You might come across as being, you know, what uncertainty? Never heard of it, right? And I'm just wondering if that, when you ask these questions, you know, if people ask for more clarification about the context or anything like that.
Brilliant question, because the answer is, of course, yes, in every direction. Most people I spoke to, I had the very easy PhD job of speaking to people who were highly educated and experienced professionals. So most of them sort of went, yes, you want to hear about all the different contexts in which I could talk about, here you go. And yes, to your point, some of them were exactly that, scientists who talk to the media a lot, who you know, wax lyrical about, if I'm at a scientific conference, I can speak to my heart's content about the actual uncertainty and how I understand it. If I'm talking to the media, it's a completely different summary of it. They might still be talking in a scientific sense, but they have to really, really bring it down to words and language about, how likely is this going to happen? Not how uncertain the data is, but how relevant is it right now to the public? That sort of idea of uncertainty, which also has another technical name, which I've forgotten. And then speaking to politicians and lobbyists, or there was really interesting crossover in the data. For example, scientists who volunteer as speechwriters for political parties, saying that entirely they would never, ever let uncertainty touch the page. It's not relevant. It's not part of the rhetoric. And that the same thing, you can weaponize uncertainty in that sort of different way, that they might be more obvious to mention the uncertainty in the data of their opponents, or they might not mention it at all, or those sort of things. So as with the previous question, even people who would say, for some cases, obviously statistics is about what's true and what's descriptive. 20 minutes later, they would be saying, but I wouldn't mention that because I really want people to vote for me, right? It was very malleable for everyone, I guess, is the answer.
Thank you very much, Samantha. I just would like to add a quick thing. So the way I think I would model those situations is that when we're talking to our colleagues, we are dealing with first order propositions such as, let's say, a certain claim about the world, and we are assigning certainty or uncertainty on a, let's say, probability scale, if that's how we're dealing with it. We're assigning it to those claims. Let's say, I think I'm certain, 80% certain that this is the case. And then you can assign these sort of uncertainties to all sorts of claims. And that's what we do, clarify, not necessarily always in a numerical way, but this is what we do. But then when it's we're talking to the general public, and let's say we're trying to influence the policy making or something, the claim is not about the first order claims. We effectively, the question we're facing is, should we accept this or should we accept that? And that is a second order claim, to which you can say, well, given everything we know, we should accept this one rather than that one. And that second order claim, there is no uncertainty about it. As far as we are concerned, as far as we currently stand, our current body of knowledge is concerned. So maybe that's why they are, when talking to other people, they're saying, yeah, to the best of my knowledge, this is where the field stands. And of course, we have to take that into account, like in the climate change report, right? They know it's a lot of it is uncertain, but given our current knowledge, there is no question that we believe that this one is better than that one currently. Still, both of them at the first order level being uncertain. So does that make sort of sense? That it's just different levels of description they're probably dealing with?
It's the same as well with that description of uncertainty absorption. right? That at some level there is a different conversation that's happening, and at different levels people need a much more reduced resolution scan of the options, but that still relies on different priorities in that decision making, which is exactly what happens with sorry, a lot of my background is in science communication in a public policy sense. A lot of that distinction is because the policymakers have completely different priorities to the scientists. They're trying to say, out of all this information, this model is true, this is going to happen, but that is not the language of what do we need to do about it. And that's sort of where those clashes happen and why the uncertainty absorption is happening at all different levels. But yes, that's entirely correct.
Thank you very much. And maybe one final question we take, James.
Oh, sure. Thank you. Yeah, thank you very much for that talk. It was really interesting. It made me very uncomfortable, which maybe part of the goal. I'm not sure. So I work, I work building scientific databases, and I run into these problems, and I don't know. I try not to think about them, and then when I wake up in the night and I think about them, I try to justify it in a few ways. And I'll throw some of those justifications out, and you can comment on them or not. They're not. It didn't end up being a question, but so I work on open scientific databases, and we have provenance in all our data. So in theory, you can go back to the sources, and you can say we got it from this paper, and this curator curated it on this day using these curation guidelines, and you could go back and you could do that. So when I say, well, at least it's open. That's one of my justifications that I tell myself. Or I know this stuff should all be right, but we make mistakes. And but we have processes and we catch the mistakes maybe eventually. And so I tell myself like, well, at least we have a process that'll go back to catch the mistakes. Or in the kind of larger question, we have, yeah, I am asking people to throw away information. I'm asking them to like classify things or according to ontologies that I've built. And then I tell myself, well, at least it was like a consensus decision in some cases. Like these were built out in the open, and you could have come to the call, or you could file an issue tracker or something, and you could fix it later. The truth is, nobody's going to do those things, and they're just going to trust me and trust the process and trust my colleagues and my collaborators and all the way along. And then I just try and be like an epistemically virtuous agent or something. Just try to do the best I can to hand out this data. But I mean, yeah, at the end of the day, it's going to be full of biases and messiness, and it's not going to be the perfect data set that I would like. So I don't know, did you ever run into those kinds of things, or is that line up with any of the things you've been researching?
Yes, this is a perfect final question, not to shut down anyone else, because this is in the broader thesis, I focus on 3 themes, right? And the themes are in relation to why quantified evidence, it's technically sort of a public policy evidence thesis more than anything else. Why is quantified evidence different to not quantified evidence, or what sets numbers apart? There's a lot of good books about what set numbers apart, but I wanted to talk about it in an evidence sense. And what I focus on is consensus and convention, the problem of context, and then the problem of certainty. And so all the authority of numbers, and this is in Ted Porter's book, Trust in Numbers, it's in a lot of other brilliant work. It's all about those consensus, and you outsource your guilt and concern to this record of communal consensus, and it holds that authority of objectivity for you. It's the same thing as saying, oh, well, I didn't mess up the recipe, like the recipe is bad, because you know in your heart you followed it to the letter and everyone else has, and that's all you've agreed with, and it's in that system. So it's what statistics is based on. And so the dynamic then, there's a quote that I didn't put in, but I really like it, which is that Girolles, who did the statistical realism, ends his book about the politics of large numbers in 2001 with this statement of statistics needs to be like, it needs to remain fixed so that life can continue its course, but it needs to be changeable so that life can change course, which is such a nothing sentence. But he's saying that the worth of all of this, the worth of the statistical project is that you have a shared context and a shared language so that we can live life and make decisions, but it needs to be able to be changed when enough people agree that the use case is different or that something has gone wrong, that you frequently go back to ground, to people with grounded expertise of the area to recheck the validity, which is something which happens less and less in the sort of rampant total quantification that we see in massive, like I'm talking massive data sets of everyone. They don't frequently go back and say, hey, does this still work for how you Indigenous community live your life? Or can we just keep calling you a nuclear family household? They don't go back and regularly touch base. It all becomes about the numbers and the mathematical reframing and secondary, tertiary analysis. But exactly, it's all about this agreement on consensus to believe in objectivity so that it can be useful. And the other quick note is just about openness, which most people mentioned as something that they really believe in. Exactly, I had a lot of worried professionals saying, well, oh, but people can check my working out or things like that, or saying that governments should publish the details more often so that people can look through it. There was a really famous case of this in the COVID lockdowns here in Australia, because we had really extreme lockdowns, and our Academy of Science made a lot of public calls to release the modelling that the government was using to say that we don't care about the decision, we want to see what evidence you're using, which I think is a flawed argument, but it did resonate with a lot of people, that we want to see the reasoning that you used if you're going to say that you're being scientific about this. So openness is a really useful tool, both in practice and in an effective sense, to make you feel better about how people can check your reasoning and make it both more accurate and more useful. That's what I'd say. But thank you very much. Very, very reflective question on the data that I got.
Thank you, James, and thank you, Samantha. Thank you, everyone who asked questions. Another round of applause to Samantha.